Hey everyone, and welcome. Today we're diving into a really cool mathematical mystery that's been hiding in plain sight, inside one of the most common shapes we know, the circle. It turns out there's a secret code, and we're going to unlock it together.
So let's start with what seems like a simple question. How in the world do you measure a perfect curve? I mean, think about it. You can't just take a straight ruler and lay it flat against a circle's edge, right? It's actually a way trickier problem than you might think.
And what's so wild is that drawing a perfect circle is, well, pretty easy if you have a compass. But measuring that curved line you just drew, that distance all the way around, that's a totally different ballgame. In geometry, this distance actually has a special name. It's called the circumference. And lucky for us, there's a secret way to figure it out.
Now, to find this secret, we don't need to look very far. In fact, all the clues we need are already hiding right inside the circle itself. So let's start with the absolute basics.
Okay, our first clue is something called the radius. This is just the distance from the very center of the circle straight out to any point on its edge. We usually just call it r, and it's a super important piece of our puzzle.
And for our second clue, we have the diameter. This is the full distance straight across the circle. But here's the key. It has to pass directly through that center point we just talked about. We call this one d.
And you can probably see the super simple relationship between them right away. The diameter is always, and I mean always, exactly twice as long as the radius. So if you know one, you automatically know the other. It's a perfect, predictable connection.
So we've got our measurements for the inside of the circle, the radius and the diameter. But how do those connect to the circumference, that distance around the outside? Well, let's try a little thought experiment to find out.
Because here's the crucial insight, the big secret. For any circle in the universe, the distance around it is always directly related to the distance across it. This isn't just a coincidence. It's like a fundamental law of how circles work.
So picture this. You take a piece of string and you cut it so it's the exact same length as the circle's diameter. Now, what would happen if you started laying that piece of string along the curved edge of the circle? How many pieces do you think you'd need to go all the way around?
All right, this is the big moment of discovery. You lay down that first piece of string, then a second one, then a third. So how many does it really take to make it all the way around the circle's edge?
And here's the amazing part. The answer is always the same. It doesn't matter if the circle is the size of a coin or the size of a planet. It takes 1, 2, 3 full lengths of that string, plus a little tiny bit extra to perfectly wrap around the outside, every single time.
Now that little more than 3, that little bit extra, it's not just some random amount. No way. It's actually one of the most famous and important numbers in all of mathematics. It's finally time to give this magic number its proper name.
That number is approximately 3.14. This is the special number that connects the straight line across a circle with the curved line that goes all the way around it.
And we call this number pi, spelled P-I, and we use the Greek letter pi to write it. It is the precise, unchanging ratio of a circle's circumference to its diameter. It's the secret code we've been hunting for this whole time.
So discovering pi is pretty awesome, right? But the real power comes from actually using it. Now that we have this secret code, we can turn it into some really practical formulas to measure any circle we want.
This gives us 2 super simple and powerful formulas. If you know the diameter, you just multiply it by pi, and boom, you've got the circumference. And since we know the diameter is just 2 times the radius, you can also say the circumference is 2 times pi times the radius. Either way, you get the exact same answer.
And check this out. We can even work backwards. Let's say we want to make a circle that has a circumference of exactly 20 centimeters. All we have to do is rearrange the formula. The radius is just the circumference divided by 2 times pi. So we plug in 20 for c, 3.14 for pi, do the math, and we find out our radius needs to be about 3.18 centimeters. It's as simple as that.
But hold on. There is one more absolutely astonishing secret about pi. You might have noticed I said it's approximately 3.14. Well, the truth is way stranger and kind of beautiful.
See, pi is what mathematicians call an irrational number. Now, this doesn't mean it's illogical or crazy or anything like that. It just means you can't write it as a simple fraction, like 1/2 or 3/4. Its true identity is something else entirely.
And this is the part that just blows my mind. The digits of pi after the decimal point, They go on forever, and they never, ever repeat in any kind of pattern we can find. It's 3.14159, and it just keeps going, on and on and on, into infinity. We just use 3.14 because it's a convenient estimate, but the real number never, ever ends.
So let's end on this thought. A simple, perfect shape that we see every single day contains a number that is literally infinite and has no pattern. It really makes you wonder, doesn't it? What other incredible mind-bending secrets are hiding in the simple geometry all around us?